The SAS demonstration video, Numeric, introduces you to numeric functions and how to convert numeric variables to character variables and numbers that were read in as character strings to numeric variables. So we're going to start by creating a temporary data set called math, and we're going to input an x and y, which are going to be numbers as we see under the data line statement. So we're just inputting two numbers, x and y. We are going to use mathematical functions and arithmetic operators to create some new variables from the x and y values. So in the first part of this program, we are going to use mathematical functions to create some variables. For example, we're creating a variable called abs(x), which we're using the mathematical function abs, which stands for the absolute value. So we're taking the absolute value of x. Then we're creating a variable square root x. We're using the function square root to take the square root of x. We're taking the log base 10 of y and creating a variable called log 10y. And then the log of y is the log base e of y, and we're calling our new variable lny. And then we're using the function int y to just take off the integer portion of y. So basically it is cutting off the values to the right of the decimal point. It's not rounding. If we were interested in rounding, we would use the function round. And here we're saying round y equals round, open parentheses y, comma, dot 1. So we're interested in rounding to the nearest tenth. If we were interested in rounding to the nearest 100th, we would have 0.01 instead. Then we are going to use some arithmetic operators. So we're going to create a variable called mult, x times y, a variable divide, x divided by y, a variable expon, which is equal to x asterisk asterisk y, which would be x raised to the power of y. And then we're creating a variable tot, which is the sum of x and y, and then diff, which is subtracting y from x. And then these are the values that we are reading in for x and y. Now what do you suppose will happen when SAS processes the data and it comes across a negative number, such as -2? Because we know that we can't take a square root of a negative number, nor can we take the log of a negative number. So it'll be interesting to see how SAS handles a situation where it's reading in some negative values for x and y. So now we're going to highlight all of this data and print it out and take a look at what our output looks like. Okay, so here are our 8 observations, and let's take a look. First of all, we see the printout of x and y. So here we have a 4 and a 0.2. The absolute value of 4 is 4. The square root of x is 2. The log base 10 of y is -0.69897. And we continue to go along. The integer value of y is 0. We're just chopping off everything to the right of the decimal point. If we rounded y to the nearest tenth, we get 0.2. Multiplying y times x, we get 0.8. Dividing, we get 20. If we exponentiate, so if we go 4 to the 0.2, we get 1.32. If we add them, we get 4.2. If we take the difference, we get 3.8. Now notice the situation in our second observation where we have a -2. Since you cannot take the log of a negative number, SAS prints out a missing, so it doesn't do any calculation. Similarly, when we do the log base e, we also just get a missing. Also, if we tried to take the square root of -15 when x equals -15, we also get a missing. And then notice here, when for observation 5, we actually didn't have a value for x. So when we used our mathematical operators, where x was in the formula, none of those mathematical variables, mult, divide, expon, tot, and diff, had a number because we were missing for x for observation 5. Now let's take a look at the log here, because I think it might be interesting to see if SAS makes any comments about these negative numbers. So if we scroll up in the log, we have lots of notes. We see here that there are some invalid arguments to the function log 10, log, and that's because of reading in these negative numbers. Also note in this log that we have this variable. It's called underscore error underscore. And this variable has a value of 1 if there is a data error for that observation, and 0 if there isn't. And this is what I would call, or what SAS calls, an automatic variable. And you can actually use this variable name in your data step. It's automatically generated each time it reads in an observation. Things that can cause data errors include invalid data, such as characters in a numeric field, conversion errors, like division by 0, and illegal arguments in functions, including the log of 0. So you can use this variable underscore error underscore, and as you do more advanced processing, you might have a need to use this variable, but it is not actually saved onto your data set. It's only used in the data step. In our second example, we're going to use statistical functions to create some new variables. So we're going to read in a different small data set, and we're going to call the data set salary. So we're inputting 3 different salary values for year 1, year 2, and year 3. So salary in 2001, 2002, and 2003. And then we are interested in, first of all, taking the average salary. So we're going to use the statistical function mean. Then we're interested in the standard deviation salary. So we're using the statistical function std. And similarly, we're interested in the max and the min. Then we're going to make use of a couple of very interesting functions. The n function, which returns the number of non-missing numeric values, and the nmiss function, which returns the number of missing values in the list of variables. So here we're creating a variable called years salary. We're using the n function, and it's going to return the number of non-missing years. So the number of years where salary had been entered for that particular observation. The miss years salary makes use of the nmiss function, and it's going to tell us the number of years when salary was missing for that particular observation. Then we are going to make use of the sum function to calculate our total salary, tot salary. We're also going to calculate total salary by adding up the 3 years using plus signs. And then notice I've added a format, $9 to each of these salary values so that you can see it printed with a $sign. Again, we can add this system-defined format when we're dealing with a number that we want to show as a $. So let's take a look at all the variables that we have created for this data set, salary. Okay, so we have 4 observations. These are the salaries over the 3 different years. Notice for observation 1, this subject had complete salary information, and we calculated the average salary. We calculated the standard deviation, the maximum salary, the minimum salary. Notice that this minimum salary is not shown in the $9 format because I didn't include min salary in the format statement. And here's our tot salary, which was in the format statement. But when I calculated total sal, I did not include that in my format statement. And we can look at that again when we go back and look at the code. For the second observation, that subject was missing salary in 01. We still got an average salary calculated and a standard deviation. And we got a maximum salary, a minimum salary, and a total salary when we used the sum function. However, when we were adding together sal 01 plus sal 02 plus sal 03, because for that second observation, sal 01 was missing, total sal in that situation was also missing. And that happened again with observation 3 and with observation 4. So if we're using mathematical operators and any one of the values to the right of our equal sign is missing, then the new variable that we are creating is going to be missing. However, when we use the sum function, it would just take the sum of whatever years were available. Now I want to print out the variables that I created called year's salary and miss year's salary and see what they look like. So now notice that for the first observation, year's salary equals 3. So these are the number of non-missing years. And since year's salaries equals 3, the missed year's salaries is 0. For this particular observation, none of the salary years were missing. For the second observation, we only had 2 years of salary entered, and so there was 1 year of salary that was not entered. So that's how the n function and the n-miss function can be used. And in the last situation, we only have 1 year of salary recorded based on the n function and 2 years of salary not recorded based on the n-miss function. In this next example, we're again going to make use of the salary data, but we're going to do a little something different with it. We're going to use the mean function with the n function to calculate the mean. So let's see what we're doing here. Again, we're going to input the 3 years of salary. We're calculating the average salary, the standard deviation, and the maximum salary. Like in the previous data step, we're also using the n function and the n-miss function to determine the number of years in which salary was recorded and the number of years that salary was not recorded. And here we've added this kind of interesting statement where we've said if n of salary 01, 02, and 03 is greater than or equal to 2, then we were going to calculate the average salary, which is the mean of those 3 years. So we're only interested for this particular statement in calculating the average salary for an observation if that person had 2 years of salary recorded. So if n of these 3 years is greater than or equal to 2, meaning that at least 2 years of salary information was available for that particular observation, then we're going to calculate the average salary for that particular observation. So we're doing something a little bit different. We're combining 2 different functions in an if-then statement. So let's take a look at how this data set looks when we print it out. So notice here, we've calculated average salary the way we did in the previous data step where we just took the average of the 3 years. In this situation, we have an average salary calculated whether there was 3 years of salary entered or just 1 year of salary entered. The second way we calculated salary, we only calculated it if we had at least 2 years of salary information recorded for an observation. So only the first 2 observations had an average salary calculated. And we were able to do that because of the if-then statement. Another question I want to ask you is what's the difference with proc means and the mean function? Proc means calculates across all observations. The mean function calculates the average for a group of variables within an observation. So we use the mean function when we want to calculate the average within an observation of a group of variables. We use proc means when we want to look at the mean value across an entire data set, like the mean age for our study. In these following examples, I'm going to be talking about the input and put function. The input function converts character variables to numeric variables. The input function can reread a variable according to a new informat. And the put function converts numeric variable to character. The put function uses the formatted value of a variable to create a new variable. So we're going to look at some examples of that. In the first instance, we're going to use the input function to perform a character to numeric conversion. So we are bringing in 3 different variables: char height, which is a character variable, char weight, which is also a character variable, and char date, which is also a character variable, even though it's a date. We've read it in as a character string with a length of 10. And so if we run this code through proc print and the proc contents, we'll see that we are dealing with all character strings. The other thing I wanted to point out to you is notice here when I did this proc print, I don't have a data equals chars. If I leave out a data equals in my proc print or any procedure, SAS will use the most recently created data set for that procedure. So with this proc print, SAS just assumes that the data set it should use to do proc print on is the data set chars. So let's run this code and see what it looks like. So here are our character strings of height, weight, and date. So these are all character strings. They're not numeric. And if we go down and look at the proc contents, we see that char date is a character string with a length of 10, char height is a character string, and char weight is a character string. Since char date is a character string, it's not a number. So we cannot use it to calculate days between two dates because you can't subtract two character strings. So in this next data step, we are going to create a data set called nums, and we are going to bring in the data set chars and convert height, weight, and date to numeric values. And the way we do that is with the input function. So here we are inputting char height as a numeric variable with an 8-dot format. So this means that it is a number that has a total width of 8 with no digits to the right of the decimal point. Weight also is going to be a number with a width of 8 with no digits to the right of the decimal point. And char date is now going to have a numeric value, and it's going to have the format MMDDYY 10 dot. So that's the informat we're going to use to create our date. So let's run this data and look at what our output looks like. So notice here that we now have char height, char weight, char date, and now we have these variables height, weight, and date. And they sort of look exactly the same as the original char height, char weight. Although you can see in the printout that char date looks different now that we have a proper MMDDYY 10 dot format attached to date. But more importantly, if we go back and do the proc contents, we see now that date and height are both numeric. So our date is now a number, the number of days relative to January 1st, 1960, and it has the format MMDDYY 10 dot. Height is a number with a length of 8. Weight is a number with a length of 8. And notice that our three original variables, char date, char height, and char weight, are still character strings. They haven't changed. The last thing I want to demonstrate for you is the put function. So with the put function, we are going to go the opposite way. We are going to take variables that are numbers and convert them to character variables. So here we're starting by creating a data set called Numeric, and we're inputting a date, which is in an informat of MMDDYY 10 dot, and then we're inputting two other numbers, age and cost. So these are three numbers that we've input, and we're just going to print out those numeric variables. So the first time we run it, and we just do a proc print with no format statement, notice that our date appears as the number of days relative to January 1st, 1960. Our age appears as age with no format attached to it, and our cost is not shown with any kind of dollar format. Let's run the same procedure except including a format statement where we're going to have age with an age format attached to it, and we're using the age format where we're grouping low to less than 20 and labeling that group 1, 20 to less than 40 and labeling that group 2, and then 40 to high and labeling that as group 3. So when we use this age format, we're not actually recategorizing age, we're just attaching this format for when it's printed out in the output window. And then we've attached the MMDDYY 10 dot format to date and the $10 dot format to cost. So let's run the proc print with the format statement. And here you see the data looks a lot nicer, easier to read because we've attached these formats. And then the last thing I'm going to show from the data numeric data step is a proc contents of it. And so we see here our variables age, cost, and date are all numeric variables. Now we want to try to convert them to character variables. We're going to create a data set called convert. We're reading in the numeric data set, and we're going to use the put function to turn each of those variables, the date, age, and cost variables, into character variables. So first of all, we have char date, and then we use the put statement, and we're telling it to put date, and this is the format that we want the new character string to appear. So we're using a date 9 dot format, and we're creating a character date that looks like the date 9 dot format, and we'll see that when we print it out. Then we're creating a character string age group. We're using the put statement, and so if age falls into the low to less than 20 category, for example, then our new variable age group, which is going to be a character string, is going to be a string that says group 1. And then finally, we're going to take our cost variable and we're going to create a character string called cost that's actually going to have the $sign in it. So let's run this code and print out our new variables and see what they look like. So here we have age, char date, and this is actually a character string, and it has the date9 format, and this is what the date9 format looks like, but this is now a string, it's not a number. Age group is a character string, and char cost is a character string. And if we did a proc contents of this data set convert, we see that age group is character, char cost is character, and char date is character. And then our original variable age is still numeric. And the reason when we did a proc contents and we only saw char date, age group, char cost, and age is because we have this statement in our data step, drop, date, and cost. And what that means is it's just not going to include those two variables in the data set convert. So when you have a drop statement, it just drops those two variables from the data set. I also want to remind you that this new variable char date that we've created is no longer a number, so you can't use it in calculating differences because it's now a character string. This completes the demonstration of numeric functions.